All right, we're continuing the properties of exponents in 6.1. This is the third day that we're talking about properties of exponents. So we'll do a really quick review of the rules of exponents that we've already covered. Zero exponent, anything other than 0 to the 0 power is 1. If you have a negative exponent, say it's a to the negative m power, then you take the reciprocal, you put the base in the denominator, and then that automatically makes the exponent positive. Or you could also start with a negative exponent in the denominator. 1 over a to the negative m power will turn into a to the m power. The product of powers is something like a to the m times a to the n. As long as you have the same base, you add the exponents, a to the m plus n. And then the quotient of powers, a to the m over a to the n. Again, as long as you have the same base, subtract the exponents. Numerator minus the denominator, unless the exponent is larger in the denominator. Then you can subtract the numerator minus the denominator. And then an additional property or a new property that we'll be talking about today is the power of a power. So for example, x to the third raised to the second power, or squared. X to the third could also be referred to as x cubed, and all of that squared. Kind of like the other properties, product of powers and quotient of powers, we can figure out the rule by writing out everything in expanded form. So what's inside the parentheses here? X to the third power, that's x times x times x. And then what you want to do is square that. Now the base is the product of x times x times x. To square something means to multiply it by itself 2 times. So here's what I want to multiply by itself 2 times. X times x times x. To square that, I multiply that by x times x times x. That's the same as x multiplied by itself 6 times, just without the parentheses. Or again, x to the 6th power. And then to figure out the rule, compare the 6 to the exponents that we had before. The power of a power, x to the third squared would be the same as x to the 3 times 2, or x to the 6th. If you're raising a power to a power, or if an exponent's outside a set of parentheses, then you multiply the exponents. So the rule, just using variables, a to the m power raised to the n power, power of a power. So we multiply the exponents, a to the m times n. And then the next property, the power of a product property. Here's the power, 5, and then the product is 3 squared times x cubed. So as I mentioned, anytime you have an exponent outside a set of the parentheses, all this means is you raise everything in the parentheses to the 5th power. So we can multiply this exponent by each of the exponents in the parentheses. 3 to the 2 times 5, x to the 3 times 5. And then 2 times 5, 3 to the 10th power times x to the 8th power. And then what I'm going to do is evaluate 3 to the 10th as well. If you're asked to simplify, you always want to take everything as far as you can go. So 3 to the 10th, since I have a constant to some exponent, I could always simplify that. Probably just want to use your calculator, make sure you're using your exponent button. So 59,049 x to the 8th. Can't simplify the x to the 8th any further because we don't know the value of x. That's using the power of a product property. And then before we go over the last property, just in general, because I use a specific example, if I have a to the m times b to the n power, all raised to the p power, that's the power of a product. Just multiply the exponent outside the parentheses by each exponent inside the parentheses. A to the m times p, that would just be mp, times b to the n times p power. And then the last property is the power of a quotient. So something like this, to the 3rd over x to the 5th power, all squared. So similar to the power of a product property, I have an exponent outside the set of parentheses here. I want to multiply that exponent by each of the exponent inside the parentheses. So 2 to the 3 times 2 power, multiplying this exponent, 3, by the exponent outside the parentheses, over or divided by x to the 5 times 2 power. And then just multiply. 2 to the 3 times 2 is 6. and then 5 times 2 in the denominator, x to the 5th. But like on the last example, 2 to the 6th is something that we could evaluate. So again, never leaving a base that's a constant to some exponent. 2 to the 6th is 64 over or divided by x to the 5th. And then just rewriting the power of a quotient property using variables a to the m over b to the n, all raised to the p power. Your exponent's outside the parentheses, so multiply that by each exponent inside the parentheses. A to the mp over or divided by b to the np is what it would end up with for the power of a quotient property.